Every organization that deals with hazards on a daily basis faces a simple yet very profound choice. Either it manages human error, or human error will manage the organization, always at great cost and often at great danger.
As managers, we fail to understand that the biggest single risk that we run is due to human error. There are lots of other kind of risks we run, like currency risk and trading risk, but human error is really the big one. It has fantastic financial consequences. Companies all over the world have just gone out of business due to human error. Workers can be put out of work. Managers can see their careers go up in smoke. It can turn your market value into nothing.
If human error could be managed through applied common sense, better rules and firmer discipline, how is it that, across different industries, error patterns remain constant, and people doing similar jobs in widely differing cultural environments make the same kinds of error time and time again?
The problem is really very simple. Wherever there are human beings, there will be human error. Fallibility is part of the human condition. That's why things go wrong.
Human error is inevitable, but there are processes in place to prevent and discourage this. This instructional video will guide you through the HAZOP approach to avoiding human error in the workplace. HAZOP is an ergonomic tool used to help identify potential hazards in a system, as well as identify operability problems so that human error can either be prevented or corrected. These hazards occur because of a deviation from the original process, so that HAZOP techniques helps employees to stick to the process and reduce human error. This tool is both qualitative and inductive, in the sense that it describes processes from the bottom up, starting with the line workers who have experience in the field where errors can possibly take place. The HAZOP tool was first developed as an aid for engineers in designing a chemical plant, but is now found in all sorts of industries, such as petroleum and food plant, and is considered to be one of the easiest process hazard analysis tools. When an organization realizes that they aren't running as efficiently as possible, or when they are implementing a new process that they want to run smoothly, they initiate HAZOP process by bringing in an ergonomist, just like yourself. From there, you will work with subject matter experts who work directly with the process, and together you will brainstorm where human error is likely to occur, using both workers' experiences and your training. You will learn the details of how to use this tool, but to give you a general understanding of HAZOP, you should know the first description of possible scenarios is created before any error is actually done. While working with the HAZOP tool, you will be dealing with hazards, harm, and risks, so it is important to note the differences between them. A hazard is a potential source of harm, and these hazards are created through human error and deviations from the planned process. An individual hazard may seem small on its own, but it could lead to multiple forms of harm. Harms are the consequences of hazards, and the result is damage to an employee, company property, or the environment. Risks aren't always necessarily identified in the HAZOP tool, since the probability and severity of harm aren't taken into account, but some specialists may incorporate risks. Human error is not random. There are reasons that it occurs, and after your training, you will be able to help realize why it happens, with the help of HAZOP. Errors can be unintentional, like forgetting to do something, intentional, like purposefully violating a process, physical, like pulling the wrong lever, or mental, including skill-based, for example, an automated routine, rule-based, if the problem is A and then the solution is B, or knowledge-based, for example, having the training to make the decision instantly. After your HAZOP training, you will be able to prevent each one of these types of human error. So, why should you choose HAZOP? First, let's look at HAZOP in context with risk analysis and risk management. HAZOP, which stands for Hazard and Operability Analysis, is an extremely basic approach to human error investigation. It is a qualitative process hazard analysis method. Process hazard analysis is a component of both process safety management and risk management programs. Safety is your main concern when developing a HAZOP analysis. Let's take a look at why HAZOP will effectively increase the safety of an organization. Firstly, it is applicable to all workers and situations. Human error can be hard to quantify. Therefore, it is important to have a system that is applicable to almost any scenario. Human error is dependent on the individual worker or operator, their interpretation of the situation, and their physical, mental, emotional, and cognitive state. Secondly, HAZOP decreases vulnerability of all people in and associated with your organization. A certain level of human error is unavoidable. Decreasing the potential for human error decreases the vulnerability of workers and decreases the potential for harm to all members associated with the organization. Thirdly, HAZOP offers preventative measures for an undetected hazardous situation. Hazards can be difficult to detect if they haven't been encountered previously. Installing a system to manage potential deviations leading to harmful situations is a preventative measure. Lastly, implementing a risk management analysis tool strengthens the safety culture of an organization. If management spends time and money to ensure a safe working environment, workers are more likely to feel an obligation to report new or reoccurring errors and hazards. In addition to safety, your next concern is how HAZOP can positively influence the productivity of a company. First off, implementation of HAZOP increases system efficiency. HAZOP is efficient because it can be integrated into the initial design process, minimizing the time, money, and energy spent in installing add-on control and safety systems. In addition to this, decreasing human error also decreases production mistakes. Human error resulting in production mistakes can decrease productivity by wasting time and money to fix or redo the incorrect process. Lastly, decreasing human error increases worker productivity. Human error resulting in worker injuries decreases productivity. If a worker is hurt, the employer must find a new worker to complete the job or wait for the injured worker to recover before the job can be finished. If another worker takes over the injured worker's project, this takes the uninjured worker away from completing another task, which ultimately affects the overall productivity of a company.
Hi, I'm here to show you how you will use the HAZOP tool. There are 4 phases to HAZOP. The first is the definition phase, next the preparation phase, next the examination phase, and finally documentation and follow-up. The first phase is the definition phase. In this phase, we need to identify who the members of our risk assessment team will be. This team is built of people from many different disciplines who specialize in their specific field. These specialists are carefully chosen in order to include people with wide and up-to-date knowledge of system deviations. Once a risk assessment team is chosen, it is their job to narrow and focus their effort as to not have too large of a scope to assess. The next phase in the HAZOP analysis is the preparation phase. During this phase, you must gather supporting data and information that will help you with the analysis. You must recognize who will be using the information you provide at the end of the study. You also must prepare for management duties, such as scheduling meetings. Your team also must have a consensus on the template format that is going to be used for recording the outputs of the study and also on the HAZOP guide words that will be used for the analysis. Using HAZOP guidewords are an integral step in identifying deviations in the operation or task in a systematic and consistent manner. These guidewords make one ask questions, stimulate thinking, cause discussion, and ultimately focus the study. It is the job of the risk assessment team to identify the appropriate guidewords that will suit the scope of the study. Once the guidewords are selected, the next phase of the study can begin. The next phase in the HAZOP analysis is the examination phase. At the beginning of the examination phase, all of the elements of the system or process being examined must be identified. For example, one process can have many elements, such as different detergents or chemicals. Next, you must apply the HAZOP guidewords to each of these elements. This allows for a systematic way to thoroughly search for deviations in the operation or process. For example, you can apply the guideword no to detergent or the guideword wrong to the combining of chemicals. Note, all guidewords and element combinations are not expected to yield a credible deviation possibility. It is simply to generate discussion and brainstorm for possible deviations. Any deviation that is brainstormed should be deemed credible before any other attention is given to it. When combinations of guidewords and elements do not yield credible deviations, there is no need to document them in your analysis. Once you have been hired by a company to analyze a specific process, your job is to identify all of the relevant elements. For example, in an industrial laundromat, one major element is cleaning agent or detergent. Now that you have identified an element, you can go on to identify all the relevant guidewords that can be applied. Let's say you chose the guideword no. You would then have to think if this guideword was credible and made sense. In this case, it is an applicable guideword because there would be a deviation in the process if there was no detergent. Remember, not all guidewords can be applied to every element, so there are situations where the deviations are not credible. If the guideword you chose applied to the element, then that means you came up with a credible deviation. You can then move on to investigating the causes, consequences, and preventative measures that can apply to the deviation. For example, if there was no detergent, the cause could be because an employee forgot to refill the detergent in the machine. The consequence of the forgetfulness of the employee would result in the clothes not being cleaned. This could be prevented by the employee checking the detergent levels prior to running the cycle, or by installing a warning light that notifies the employee when the detergent is running low. If the deviation was not credible, you should consider whether or not your team brainstormed all of the possibilities that apply to that guideword. If you believe you had optimal brainstorming, then you should go back to select another guideword and start the process again for that word. You must go on to make sure that you and your team have captured all of the guidewords that relate to that specific element. Next, you must make sure that you have examined all of the elements that pertain to your process. The final phase in the HAZOP analysis is the documentation and follow-up phase. There is a template recording form that the HAZOP analysis uses to document the findings of the risk management team. This is given to the company for their reference. It should then be verified that there is a satisfactory process that exists for the actions that are assigned by your risk management team. For example, if you propose the warning light to notify when the detergent is empty, it is the company's job to hire someone to install it.
Next, we will look at the measurement properties of the HAZOP tool. The HAZOP system approach can be a very reliable tool in preventing human error within workplaces and organizations, as long as it is developed and implemented properly. There are many factors that determine the reliability of the process. These factors include, firstly, the accuracy of the drawings and data used as a basis for the study. Do the blueprints for the plan include every step? The experience level of the team leaders. Are they highly skilled in the brainstorming and developing the HAZOP plan? Is the team that is using the proposed safety plan able to implement it effectively? Lastly, is the team able to maintain a sense of cohesiveness and continuity among its members?